Hi guys, good evening. To those who joined by YouTube, good evening guys, Uday, Divya, everyone those who joined through YouTube. So we finished with linear search yesterday, right? Am I audible to everyone clearly? So today I have plans of explaining the next search, which is also very widely used. Can anyone tell me what search is that? The screen visible to everyone, the paint screen. One person from the Zoom beings communication with me. Vignesh, Vignesh is there? Is Vignesh there today? Am I audible to you, Vignesh? Yeah. So you be in sync with me and just no, I'll be in communication with you. So are you able to see the paint screen? Yeah, perfect. Okay, so if whatever I'm explaining is not in sync, Vignesh, you can highlight it to me over the chat because I'll be flipping to YouTube once in a while, but I'm available on Zoom the entire 2 hours. So Zoom guys can highlight it to me if there's anything which is not in sync. Okay. So today's search, which we are going to do is binary search. So binary search, as I explained, is very fast, but there's a prerequisite that data must be sorted if you are trying to run binary search. So let's say if I have some, okay, so what binary search does is it keeps on narrowing down the search area. Okay. So binary search will in each iteration will filter out the unwanted information. Okay. So let me give you all a real-time scenario of binary search. So let's say this is a telephone directory. Okay. So I'll take this as a, and the names in a telephone directory are alphabetically sorted, correct? So first is page for A and then blah, blah, blah. Okay. So I'll just write it down. So these are the names. Okay. Let's say the names are sorted in alphabetical order in this telephone directory. So if someone is searching for the name Henry, let's say you're searching for the name Henry. So A is at which index? 0 index. And Z is at 25 index. Okay. So now I'll mark the indexes also. So it becomes easier for you all to understand. 20, and blah, 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 till 25. Okay. So I'm searching for the person Henry in the telephone directory, and the names are alphabetically sorted. So first, it will always search at the mid position. So when I open this telephone directory, so let's say this is on page number 0, page number 1, and there are 1,000 pages. Page number 1,000. So on which page will I have the middle records? Middle record will be 12, right? 25 mid is 12. So first I'll calculate the mid. So in each iteration, we will calculate the mid first. So now my mid is 12. So I will search at the mid. So here I will be on page number 500 because it is a sentence, right? And what name will come appear over here? Mike and Michael, all those whose names start with M. Okay. So I'll say no. This is not what I'm searching for. Now, whatever I am searching for, will it be towards the right or towards the left of Michael now? Names are alphabetically sorted, right? So where will Henry be? From page number 1 to 500, or will it be from page number 500 to 1000? Yes. Let me switch to yes, anyone? In which range will my record which I'm searching for will be? Will it be between page number 1 to 500 in this range, or will it be in range 500 to 1000? So now as my name is H is less than M, so I will. So first I was searching for where my first and my last. My first was page 1, last was page number 1000, and mid was page number 500. Now once I open the center and I see Michael, then I will tear the right side of the telephone directory. So this much I will tear and throw it away. Is not there in this part. So now my search will be from where? 0 to 11. So my first is at the very first position. My last has now moved to mid -1. So where I have my last moved to? So if you're searching and it is there towards the left of mid, the last will move. So last will come to mid -1. First was at 0. Now this will recursively keep on iterating. Okay, this will keep on iterating now. Okay, we can use it with recursion and without recursion both. So I'm using a iteration. So now my first is at 0, last is at 11. So my iteration will go till my first is less than last. Till my first is less than last, my iterations will continue. Okay, so iterations will continue. Now what is my value of first? 0. Value of last is 11. Is 0 less than 11? Yes. Now calculate the mid. Calculate the 0 plus 11 divided by 2, 5.5. So remove the decimal. So mid will come at 5. 5. I always open the mid page. So what names I see? I see names such as Frank, Francis. I see such names. So is this what I'm looking for? No. Then what I'm searching for, is it towards the left or towards the right? So as it is towards the right of F, so if it is towards the right, the first will move. First will come to mid +1. So first will come over here to 6. Now I'll tear off the left side of the telephone directory because my data is there. Now my new range. Now my new range is between 6 and 6 then last. Till your first is less than last, you have chances of getting that number. If my first overtakes the last, then no chance of the number. So if the first overtakes the last, directly you can say not found. So as long as the first is less than last, there are hope can be found. What is first? 6. What is last? 11. Is 6 less than 11? Calculate the mid. 6 plus 11. 17. 17 divided by 2 is 8. Okay, the mid is at 8. So when you open the mid, you get names such as EN. Okay, all names starting with I. So is this what you're looking for? No. So I know that it is sorted. So I will bring my last to mid minus 1. Because I know it will not be in this range. So if it is towards the left, my last will move. Okay. And now the new range will be over here. Okay. So now still first is 6 and last is 7. Is 6 less than 7? Yes. Okay. You can say equal to also if you want. Till your first is less than or equal to, you can use. Now is 6 less than or equal to 7? Yes. And now calculate the mid. 6 plus 7 is 13. Divided by 2 is 6. The mid is what? Mid comes over here. Okay. So when you open the G page, you will see names such as George. Now, is this what you're looking for? No. Right? So your number will be towards the right. So if it is towards the right, first moves. So now first we'll go to mid plus 1. So first comes over here. And I'll eliminate this part also. So now I have zeroed down on my is first less than or equal to last. True. Calculate the mid. 7 plus 7, 14 divided by 2 is 7. Is the number we are searching for found at H? Yes. And I will say number has been found. So like this, on each iteration, you will try to remove the half of the data and narrow down your information and gradually till you come across the correct data. So on this principle, you're okay. Let's come again and let's try to see how it works. Okay. So first is 0, last is 25, mid is 12. First search at the mid. If you find the record, so if I was searching for Michael, I would have said record found. So at very first iteration, I would have got, in one iteration, I could get the data. But I was not searching for Michael, I was searching for Henry. So I will check whatever I'm searching for falls into which part, left part or right part, green part or red part. If it falls in the green part, move the last to mid minus 1. If it falls in the red part, move the first to mid plus 1. So in this case, what will I do? I will move the last to mid minus 1. Because it is data is towards the left side. So what did I do now? So I moved the last to. So in the first iteration, I moved the last to mid minus. Okay. And you'll always search between first and last. You'll always search between first and last. So first was at 0, last comes at 11. Now whatever unwanted data is there, that is being removed. In each iteration, I am removing half of the data always. So this works in logarithmic time. So in every time, we will remove half of the data. Okay. And now you can keep the iteration count also. How to search for Henry, you can keep a count on the iteration count also. So now I finished only one iteration. Now first Is it less than equal to last? Till when will the loop run? You have to check this. The loop will run till the first is less than or equal to last. Okay. Calculate the mid. 0 plus 11 is 11. 11 divided by 2 is 5.5. So mid will come over here. So I will first search. Am I searching for F? No. Is what am I searching for greater than F? Yes. So if it is greater, then first will come to mid plus 1. Okay. And you'll always search between first and last. So this data is as good as it has been eliminated. It's like you have torn all those pages of the directory because data will not be there in this part. Okay. Iteration count has become 2. And now is 6 less than equal to 11? Yes. Count the mid. 6 plus 7, 17. Mid becomes 8. 17 divided by 2, 8.5. Mid becomes 8. Am I searching for at I? No. What am I searching for? Is it greater than I? No. It is towards the left side. So last will come over here. Mid minus. So if it is towards the left, move. If it is towards the right, first will move. Now this is good. Remove it. Now 6 plus 7, 13. 13 divided by 2 is 6. Mid comes at 5. Mid comes at 6. Am I searching for G? No. What I was searching for is greater than G? Yes. So first goes to mid plus 1. So first comes over here. And now first plus last both gives me the mid. The mid also comes over here. And whatever I'm searching for is found at mid. I will terminate the loop and say found. Okay, got this, guys? So this is how your. So let's try to search in an array now. Okay. So let's try to search in an array. But the prerequisite is data has to be sorted. So let's take an array of 6 or 8 elements, whatever you all want to. Let's take 6 elements. Okay. And those data. Okay. So let's try to work on this. And we'll try to do the coding on this. And then we'll try to solve some real-time questions which they ask in the interview based on binary search. So today's program will be some heavy lifting. So I would want everybody to be ready. Today we'll do some sort of heavy lifting. First week, right? So by first week, you all should be comfortable with solving programs of this level. Just the explanation of binary search program will follow after the explanation. When the explanation is thorough, programming should not be a problem. Or when I explain the problem, a program, you all should easily understand it. Okay. So now I'm entering data in ascending order because I want to do binary search. Okay. So be wise enough. If you're given an array of unsorted elements, first sort it and then do binary search. Okay. So now if I'm searching for, let's say 50 or whatever number you want, I search for 50. So my element which I'm searching for is 50. Okay. And this is my array ARR. So my starting of the search is from which point? So I'll mark my first as the first index and the last as either mark it the size of the array or mark it the last index, whatever you feel convenient. Okay. So now I'll try to write the pseudo code over here. So first will be 0 and last will be ARR dot length minus 1. Okay. Okay. First is 0 and last is length minus 1. Then what will, till when will my loop run now? As mentioned, my loop will run till my first is less than last. Okay. Now be careful. Okay. So first is 0, last is length minus 1, while my first is less than equal to. Okay. Be careful, guys. This should be less than equal to. Okay. This should be less than equal. So is 0 less than or equal to 5? True. Come inside and first calculate the mid. So will we calculate the mid? We had done yesterday. First plus last divide by 2. Okay, and mid is an integer value. It's not of decimal value, it's an int value. So we'll truncate the decimal. So 0 plus 5 is 2.5, 2.5 divided by 2. Truncate the decimal. Mid will come to 2. So I'd always search at the mid position first. So is this what I'm searching for? If my ARR of mid, that is 30, is that what I'm searching for? If I get it, so if I was searching for 30, I would directly say found and no need to search ahead. I will say found and I'll break. I'll found and I will break the loop because I've got the number. But for check whether it is towards the right or towards the left. So if I'm whatever number I'm searching for, if it is greater than the mid, means it is in the right part of the array. Then if it is towards the right part, what will happen? Your first will go towards the mid plus 1. So if it is, okay, as it is only one statement, I'm removing the bracket. I need some space over here. So if it is not equal, neither it is greater, so it is less. So if it is less, means it is towards the left part of the array. So your last will go to mid minus 1 and loop completes. So I have displayed for the found part. Now what for the not found? So what, when do I have no hopes that the number will be found? So if my first overtakes the last, then there is no chances. So always after the loop, you need to check for not found, right? Same you were doing in linear search. So if the first overtakes the last, then you have no chances of number being found. So you will say not found. So this is the dummy code I've written. So let's try to implement it. I hope you all are able to see the screen, everyone. And now I'm switching to my programming screen. Please let me know once you all see my programming screen. Yes, Vignesh. Thank you. So let's come over here now. So we'll be in day 5 today. And let's make a class. Binary search. Then. Okay, I have checked mail. Let's check this. Integer ARR. This is pretty straightforward. $60. Number I wish to search for is 40. Okay, so I'll take the first and the last. What is first? First index. What is last? Last index. And my while loop will say till my first is less than or equal to last. What do I need to do? Calculate the mid. It should be first plus last divided by 2. Okay. First plus last divided by 2, and then we will search for the element. Okay, what we are searching for. If it is there at AR of mid. If it is there, I'll say south found and I'll break. If it is not there, I will check which part it is in. So if whatever I'm searching for is greater, if it is greater, means it is toward the right hand side. And if it is toward the right hand side, the first will move. And if it is toward the left hand side, then last in. Okay. And if my loop terminates, and if in this switching, if my first overtakes my last, I'll sys out not. As simple as that. Okay. So let's save it. Let's run it and check. So when I said 40, it is showing me found. Let's check for 77. It is there. And 77 is showing not found. So try doing this basic program. Okay, I'm sharing my screen. I'll also push it onto GitHub. Those who are accessing from GitHub can check it from there. I need to do now do some real-time programs using binary search. So try to increase the intensity of programming now. This is no doubt. Yes, you're able to see my screen, guys. Vignesh, am I audible to you? Yes, please try to code this. I've pushed the code onto the GitHub repo also. So those who are coding from GitHub from there. Let me check what the YouTube guys are doing. Yes, try solving it and see if you can find any area of improvement over here. Okay, if I want to display, okay, how many iterations it took, okay? So these are how many elements? 6 elements. So it will take log 6. So max to max it will take logarithmic 6. So if I have a loop counter and the number of time this loop is running, if I increment it, and then at the end I come and display the loop. So this will take max to max log of 6. So even to display not found, it took maximum 3. So what is log of 6 to the base 2? I'd explained you all last time around. So take 6 and try to divide by 2 recursively and see how many steps 1 comes. So 6 divided by 2 is 3. 3 divided by 2 is 1 and some 0.5 on top. Okay. So 2.5, which if I round it up to an integer becomes 3. So max to max in 3. Worst case, it will take me 3 iterations to tell whether the number is found or not found, not more than that. Okay. And if you look for the number which is at the center, that will be the fastest performance. So if you look for 30, that will give you in one count only the number is found. Iteration count also best performance of binary search is when the number we are searching for is at the center location. So code this. Now I want to also show at which index it is there. So I'll also now make a new version of this as we were doing yesterday. Binary search demo 2. Now I want to show which version it is. So it is always a good practice that we use functions, right? So it's a good practice that we put all this code into a function. Okay. So we call a function binary search and we pass the array and the number what we are searching for. And create the method and write the code over here. This is always a good practice. So this is a non-parameterized function. So it is a parameterized function, not returning any value. The function itself is displaying me found and not found. Okay, but now I want the function to return me the index at what index that number is there. So I'll copy it. And now what we will do, we will ask for the index at which the number is there. So what will we do now? This will return me an integer. So now instead of saying find, I will just return the mid. But it is finding at mid position, right? Okay. And if the number which I'm searching for is not there, I will return -1. I'll return minus. Okay, I'm sharing my coding screen, Vignesh. You're able to see my coding screen? Okay. So now so now what I did is I copied the entire code into a function and I called the function. This was my version 2. But now I want the function to return me the index at which the number was found. So I come here, I make the binary search function, which returns an integer. So now I want this function to return the value. Okay. So I'm passing the array and the search. And now what I'm doing is if I find that, I'll just return that mid index. And if I don't find, I'll return -1. Okay. I'll save it now. Okay. And this we will not do anything, but this is unreachable code. Okay. What is this happening over here? The method, yeah, it is returning a type of window, returning mid over here and returning -1 over here. Yes. What, what is it doing over here? No, but it's not over. 1 second, guys. So this function should return an integer, which I'm returning a mid over here. And if the loop breaks, yes. So add return statement, yes. So here for a conditional, so here we are returning mid, and here we are returning -1 if it is. So what you can do is you can return mid over here also. Return the mid. The mid is declared outside, so we can declare it over here. Okay, so you can just break the loop over here and you can return the mid. Slash to 0. Okay, so if the number is return mid, so if the first is greater than last, return -1, else return the mid. So let's try to run this code and check. And now we will try to check over here. If my index is -1 means the number has not been found. So we are displaying not found. Else we will say this out found at index plus index. So let's search for 30. Where is 30 found at? 30 is found at index 2. Okay, let's check first. 77 is not. Okay, so you can try this. And if you want to check for that ternary operator, if you want to go with ternary operator, what we can do? In system.order println, check for this value. If it is true, display this. If it is false, display this. Okay. This should be even better. I'm pushing all this code. This was a basic example. Now we'll take a programming use case using binary search. And we'll try to add all what we have learned in this week into one single program and try to implement that. Okay. If counter is not used, we can remove this. Okay, so try solving this. Then we'll start with an. So I'll share a problem statement with you all, and we'll try to solve that problem statement. Let me switch to the YouTube guys and check what they're trying to do. Yes, all good, guys. Those are practicing over here.
Yes, your name?
So guys, just go through this question and see what you're going to understand from this. Then I'll explain what we need to do. I'm preparing the question, then I'll unmute myself. Okay. See, so this is what I was preparing for all the question. First, we need to take an input array from user that will be random numbers. Then first you need to sort that. Okay, so we have done using 4 sorting techniques. So you use any sorting technique to sort that array. Okay, whichever technique you feel better. We have written functions for all of them, so we can use any function. And then once it is sorted, now the real challenge lies over here that after this sorted, okay, the sorted, rotate the array into the mid. So rotate means mid means this is the size of this array is 8. So the mid will be 4. So I need to left rotate 4 numbers. So I need to left rotate 4 numbers. So first number 1. Okay, so I'll just show you all the rotationals. How we need to do the rotation. So what? Okay, let's copy this. Okay, and I'll paste it into a fresh paint screen to show you all the rotations. Now I'm visible, right? Jignesh and audible also? Yes. Yeah. So now rotate this on mid. So the size is 8. So mid will be 4. So left rotate this 4 times. So what happens is I take the first element and put it at the end. This is one rotation. Okay. The one rotation has been done. Like this, I will do 4 rotations. So take second number and put at the end. Third number, put at the end. And the fourth number and put at the end. So after rotating this array on the mid, this array looks like this. 6, 7, 8, 9, 1, 2, 4, 5. That's what I've shown over here. 6, 7, 8, 9, 1, 2, 4, 5. Okay, so that would be step 2, rotation the array. And step 3 would be now can we do binary search on this array? That is what is the question the examiner has asked. That he needs a program to search on O of log n complexity. Okay, he wants it in log of n, means binary search. So is this array appropriate enough that we can carry out binary search on this array, or is this not suitable for a binary search? Binary search, what is the prerequisite for binary search? That array must be sorted. So is this sorted array? So how will we carry out binary search on this? Let me check on the YouTube, guys, what they have answering. Okay, yes, you can take a screenshot. Have you taken the screenshot, yes? Yeah. So now will we do binary search on this? So if you observe, this is array sorted in 2 phases. This array is sorted in 2 phases. So you will have to be vigilant enough. You see, this array is sorted in 2 phases. This is the green array which is sorted, and this is the red array which is sorted. So we'll have to alter our logic. We'll have to do binary search only, but with some complex logic. Okay. So that's what I wanted to explain. So let's get going and let's start with the first part. Okay. So search user questions. Okay. Now you should be, after the first week, this is what I expect you all to reach at, and such level of questions you all should be able to answer. And these questions should not be confusing for you all. Okay, see, we take the array, we sort it. Once sorted, we rotate on the mid. So there are 8 numbers. So mid means 4. So these 4 goes over here, and these 4 come in the start. And then it is saying search for index key 8. At what index is 8? 0, 1, 2. It is position 3. Okay, position 3 or index 2, whatever you feel like. So let's get going with the program and let's start with the first step. Okay. Let me know once you see my coding screen, Vignesh. Yes. Eclipse is visible, right? Yeah. So now let's try to solve this. So I'll say, okay, so I'll make a class. Okay. So let's call it as array sort rotate and search. All three things we'll do in one demo. We'll do all three applications in one. First, who can help me with the array? If anybody is coding parallelly with me can code. Okay, so the array which I have is 5298, 5298, 6176, 5298. Okay, give any random number. 5298, 6147, 6147. Okay. Okay, so this is the array. So let's try to do it step by step. So first step is searching. Okay. So we have a searching. So which search you are sorting, right? First is sorting. Why is this sorting you want? Let's say I want to sort using merge sort. So I have this merge sort over here, right? So I can, so in this merge sort, this is not a function, no? Okay, we have a function called as merge sort. In the merge sort class, we have a function by the name merge sort. So let's you reuse that code. Okay, so wherever possible. So let's make object of the merge sort. So it will ask us, is in the D3 sorting? Yes. Okay. Make the object name ms this new merge sort. And now ms we call, so in this merge sort, we have a function called as merge sort, right? And that's a static void function. So when I leave over here, ms dot ms dot is not able to view that function from here. So we are not able to view that function. It's a private function, right? So now I'm calling ms dot merge sort. And what do I need to pass? The array, the first index, and the last index. Okay, so I'm just reusing that code what we did last time. So this array, so we can check this out. Array before sorting. Array after. So let's check if the merge sort is working fine. Okay, I did not print the array. Right click, run as. So this is working now. Okay, the sorting is working. You can use any technique. Okay, you can use any technique of sorting. If you want to use bubble sort, so we have this function over here, bubble sort. This also is private, so we can make it public. And if you want to use this, then you have to use this class over here. Okay, so I'll comment out this code. If you want to use bubble sort, then we use make object of the bubble sort, and then to the bubble sort, I need to pass the array. Okay, all I need to just pass the array. So like this. All I need to just pass the array. So we have BS. Using BS, we can use bubble sort. Okay. So system.out.println, if you want, you can put over here merge sort. If you're using merge sort, this, and if you're using bubble sort, the same thing. Right click, run as Java application. Okay, 5298614712456789. I'm using bubble sort. Whichever sorting. Let's use insertion sort now. Let's try to do with insertion sort. So make this function as public and comment this out. Make object of the insertion sort. Insertion sort is the beauty if we start using functions. So directly you can copy this code and paste it over here. And with is, you can call this function. Okay. Commented this out. Right click, run as Java application. So ascending order over here. So you can use it in ascending order if you want to do. So what changes we have to make over here? Your temp is less than, right? Save it. And if I run it, ascending order. Okay, so this first step you can use by whichever class you wish to do. Okay. Now I need to rotate this. So I'll make a class called rotate array, and I will rotate the array. Okay. So we'll rotate on the mid, right? So we'll rotate this array on the mid. So first calculate the mid. That would be what is the okay. I've not hard coded the size. So directly you can say ARR dot length, right? Mid. Okay. So I'll make a object of the array class also. You're able to see my coding screen, right? Everyone? Yes? Someone can confirm? Vignesh? You're able to see my screen, right? I hope I'm in sync. Hello, am I audible to you all? Can anybody confirm the YouTube guys? Yeah, okay, so you're able to hear. So let's come back. to here. So I'll make object of the array rotate class. Array array is rotate array, right? AR is new. Now with this AR, I will call a function called rotate array. I'll pass the ARR and I'll pass the mid. I need to rotate this array these many times. Left shift this array these many times. So let's go over here and let's try to. How many times do I need to rotate the array? These many times, right? So I'll do a for loop. If I equals to 1, I less than equal to mid, and I less. So this loop will go 4 times. Now, how will we carry out the rotation? So what we do is they know how the rotation. Okay. So this is my array before rotation of 4, and this is my array after rotation of 4 times, right? I'm sharing my paint screen to you all. So this is my array before the rotation 4 times, and the other indexes 0, 1, 2, 3, 4, 5, 6, and 7. So what I'll do is I'll run a loop wherein I'll take the 0 index into 10. Okay. So I'll take the 0 index into the temp variable. So whatever value is there at the 0 days, I'll take it into 10. Okay. So ARR of 0. Now temp has 1. And then what I'll do is I'll run a loop J, which will start from 1 index till the last index. Okay. So we'll run a J, which will start from 1 and J less than the, we'll go till the 7th one. Okay. So J less than ARR dot length. So this will start from 1 and will go till 7. So I need to rotate the rest. So now I is at 1. What I'll do is I'll take the element at I index and shift it 1 towards the left. So how will I do that? The element at index J will go to element at index J minus 1. This task I will do 7 times. With the arrays of 8, 7 times I'll do this. So this is J, right? J is 1, J, and this is J, okay? J plus. So J is at 1. So every time this I will do this step. I'll make the first number go in temp, the index at 0 go at temp, and then a loop which starts at 1 and goes till the left. So 1 is less than 8. Yes. 2 goes at here. J plus plus. 2 is less than 8. Element at 4 goes over here. and j plus plus. 3 is less than 8. Yes. Element at j goes at j minus 1. J plus plus. 4 is less than 8. Element at j goes at j minus 1. J plus plus. 5. 5 is less than 8. True. Element at j goes at j minus 1. J plus plus. J goes to 6. 6 is less than 8. Element at j goes to j minus 1. J plus plus 7. 7 is less than 8. Element at j goes to j minus 1. J plus plus. J becomes 8. Okay. Now is 8 less than 8? No. Loop will break. And when my loop breaks, I will put temp. At which index will I put temp at? Temp will I put at which index? 7. So where is j? J is at 8. So I'll put my temp at which index? ARR of j minus 1. You put the temp. So this was the first iteration. So I have done a for loop, right? I have done a for loop which you run 4 times, correct? At the start, I have done a for loop which you run 4 times. I equal to 1, I less than equal to mid, and I plus plus. Okay, this you will carry on. The first iteration is done. Now I plus I becomes 2. Is 2 less than equal to 4? Yes. Error of 0 put it in temp. So what is the error of 0 now? Error of 0 is 2. So 2 will go into temp. 2 will go into temp. Now loop will start from one index. Again, j will come back to where? Here. So we'll come back to this is my indexes, right? So where will j start from? J will start from index number 1. And we'll go till the length. So now 4 put it at minus 1. 4 put it at minus 1. Okay. So like this will keep on iterating and 4 times. So now 4 will go the next time 5, the next time 6. So like this, I will have 6, 7, 8, 9, 1, 2, 4. Okay. So let's try to. Is Ankul, you have any issue? You can put on the chat. So now let's try to code this. Okay. So let's try to code this now. So this loop will go. So what will I do every time? I'll take a temp. So what will go into temp? Error of 0. And then I'll run a for loop again. Integer j. So I'll declare j first, but I might need it outside. So j equal to 1. J less than ARR dot length and j plus plus. And what do I do? Element of j goes to j minus 1. And once the loop will terminate, I'll put the temp at j minus 1, right? This is what we had discussed. Let's just cross check once. 1 present mid I plus plus. Yes. 0 goes into temp. And I take a j. J starts from 1, goes to the less than length. And j goes into 1 minus. And the loop breaks. Put the temp into j minus 1. Yeah. This makes sense. So let's try to display the array now after rotation at mid. Yeah, array. Try to display the array after rotation at mid. After this, so you can say before sorting, after sorting. Okay, whichever technique you're using, that is the material now. We can comment this out. Before sorting, after rotation at mid. Let's check it out if it is working fine. Run. Okay, so original array 52986147, sorted 1 2 4 5 6 7 8 9 and 6 7 8 9 1 2 4. Now we need to do binary search. Okay, so we'll ask for the user what number you want to search for. So I might need a scanner over here. Okay, and I will sys out. Enter number to search. Okay, and I'll take it into the variable search. sc.text. Yeah, so now I need to search this. So now I need some enhanced sort of binary search. Okay. So I'll make a class for that also now. New class, okay. And I need some enhanced binary search because enhanced binary search I need. So I'll make a class enhanced binary search. And now I'll make an object of that class. EHS equals new enhanced binary search. Now to this EHS, I will call a function search, let's say, search data. What will I pass to that search data? The array which I am searching for. Okay. And the first index, the last index, and the numbers. Okay. So this is my this function. So array, my first index, my last index, and the number searching for. Okay. Interesting. Okay. So after the rotation, now I need to search. So to this array, I have now. So where is my first pointing to? First is pointing to which index? So when I call the search, first is pointing over here and last is pointing over here. And the number I wish to search for, let's say I want to search for 8. Search has 8. So what it does is, it will first search for the mid. It will first search at the mid position. So if I was searching for number 9, assuming if I was searching for number 9, so how would you search over here? Directly you will say if the number is that AR of mid, you will say return. So let's first do that. So calculate the mid. Mid will be first plus last divided by 2. So my first is 0, last is 7, and the number I'm searching for is 9. Okay. So what is my mid now? Mid equals to 3. So I will check for this if my number what I'm searching for is found at the mid. Okay. Directly I'll return the mid. So let's say this function returns an integer. This function returns an integer. So you got to store it into the index. Okay, so we'll store it into the index. Okay, so let's try to go slow and steady. So if the number which I was searching for is at the mid, directly I will say return mid. But now if it is not there at the mid, so it's pretty simple. Now if I'm searching for 8, now 8 falls under which area? Green area or red area? Green area. So I will check if that number is greater than ARR of 0. So if the number is greater than ARR of 0, means it is greater than equal to, okay? If the search, if it is greater than or equal to ARR of 0, then it is in which area? Then I'll do the binary search in which area? If the number is greater than ARR of 0, means it is greater than 6, I will search it in which area? So if the number which I'm searching for is greater than the number at 0 index, so that is it is greater than or equal to 6. So it will be in which area? Which number is greater than or equal to 6? So it will be in this purple. See, it is not there at 9, because if it would have been there at 9, it would have displayed. So now we'll have 2 areas of search. So either 0 to this or 4 to 7. So we'll have to do it like this. So if I'm searching for the number, if it is greater than 0, then it will be in which area? So I'll call binary search. Okay. So I'll call the binary search program. I'll call the binary search method on which array. So I'll call binary search function searching on this. Okay, this will go in else. Okay, as I've given return mid, so I'll say in this ARR. Okay, so if it is there, okay, then I will check else if the number which I am searching for is greater than or equal to the number at 0 index. If it has 0 index means 6, 7 or 8 is the option, but 9 is not the option. So 6, 7, 8 means call binary search. This is sorted array. So call binary search from 0 to 2. So how will I call 0 to 2? 0 to mid minus 1, correct? So start the binary search on this array, starting from the first till mid minus 1. And this will return me the index. I will return that index to the user. Okay. And if it doesn't go into this, so if it is not equal, no, it is greater, mean it is lesser. So then I will call the binary search function. Okay. And I will search in which area? Mid plus 1 till the last. Okay. I'll search in the area mid plus 1 till the last. Okay. And now you write the binary search code over here. So now you can write the binary code, or you can pick the binary search code if you have any. We had this fourth one, right? Which would give me the index, right? So I can use this also. If you want, I can directly use this. So we can use our existing classes. So we have a binary search demo. I'll make that object. So in the enhanced binary search, I'll make object for binary search. Okay. And now with using that BS, I can call the binary search method. What is the name of the method? Binary search, okay. Passing the array. Okay, but here I'm just passing the array and the search. Okay, and here I am passing array first, last, and mid. Okay, so I'll have to call which method? I'll have to. Okay, then I have to write my own method, looks like. I'll have to write my own method over here. Okay, so we'll not use this class. We will directly write our own binary search method. So write it. Okay. Just create a simple binary search method. Same method which we did at the start. We'll just write the same method. Okay. First, and this is my last. So, and which number is searching for? We'll pass that. So we'll search from first mid plus 1 and the number I'm searching for. Okay, so I'll rewrite this code again. Just write binary search again. Why is it going towards the right? Unnecessary. Okay, so let's try to do the binary search. Okay, first this I is my last. Okay. So what are the logic of binary search in the start, which we had done? I'll just copy that. Okay. Okay. So till my first is less than last, I don't need the loop counter. I'll calculate the mid. If it is found, I'll break. Okay. And then I'll return here -1. Else I'll return the mid. Okay, and this will return an integer. Yeah, this will be my binary search. Okay, what we have done initially. Okay, mid was declared inside, so it is not able to locate mid. So let's declare mid outside, and let's write like this. Okay. Now this should make sense. Initialize it to 0. Okay. So I'm calling binary search on this array from this index to this index, searching for this number. Else I'm calling binary search on this array from this index to this index. So calculate mid. If I find the array, I'll return. Else I'll return -1. So this will return, and whatever it returns will come over here, and then we can check. Okay, we had to check this last time also. Okay, we had checked that last time also here. So we can directly put it over here. Okay, we can directly put that over here. Index is 1 not found and found at index. Yeah. So I guess this should complete the entire end-to-end. Let me run and check, and then I'll again give you a demo. Okay, I'll just remove the unwanted imports. Control-Shift-O will remove all the unwanted imports. Okay, let's right click and run and check whether it's working. So 529861478967891245. Let's search for 9. It says found at index 3. 0, 1, 2, 3. Perfect. Let's run again. Let's search for 7. It says found at index 1. Perfectly correct. And let's run. And let's search for 5. Found at index 7. That also correct. And let's search for 27. It says not found. So all the use cases we covered. Okay. I'll push this code and then I'll explain this code line by line. Okay. Let's first push this code first. Okay. And then I'll explain your code line by line. Okay. Yeah, I've pushed the code to GitHub. If anybody is doing pair programming with me, can refer it from there. Now is the paint scene visible, guys? Yeah. So now let me give you all a walkthrough. First, taken the array, sorted it by any of the techniques. Okay. Technique is what in the question I have mentioned. They mentioned of n log n. So n log n means it's merge sort. So we should have merge sort this. Okay. So irrespective, if you want to use merge sort, you can use a merge sort method. Again, we did yesterday, right? Day 3. Yeah. So if you want to use, you can use a merge sort. So of this class, okay, you can use merge sort. So after merge sort, okay, once see I've used over your merge sort. Okay, so if you want to use merge sort, you can use merge sort. Yeah, because that is what the question is demanding that you should be using. Yes, yes. Sir will keep on sharing the attendance link after every 5 minutes. So you can hang on. So do a Control-Shift-O, merge sort. Okay, once done. Then second step was to rotate the array on the mid, make a rotate array, and I pass this array and the mid, and we rotate that array. Okay. So let's share the attendance sheet again. So how we rotate it on the mid? Now this mid is 4. To the left shifting, and each time I'll take the first number into temp, shift all the numbers towards the left, and then put the temp at the last. Okay. This was done rotate. Now this was a bit challenging that we're doing binary search, but the array is not completely sorted. So we did the enhanced binary search. Number which I want to search for, the entire search, and I pass the entire array, first index, last index, and the number I wish to search. And I go to the enhanced binary search. Okay, so this is interesting now. Okay, so this is my array, first index, last index, and search. Calculate the mid. Was search at the mid only. If you get at the mid, directly return the mid, that it is found at mid. If it is not there at mid, so this is a bit challenging. Okay, so if it is not there at mid, then what we need to do? So I'm checking if the number is greater than or equal to the zero index. If the number is greater than or equal to zero index, it will be over here in the green zone. But I'm excluding mid because we have first searched at mid. So if it is greater than or equal to zero, it will be at purple indexes. And if it is not, it will go with the red indexes. So what is the purple index starting from? So I'll call a binary search, normal traditional binary search from on which array this ARR starting at index 0, 0 is with first, 2. So when my mid is 3, I will say mid minus 1, right? So if it is equal, I'll display found at mid. If it is not equal, I will search if it is greater than 0. And if it is not greater than 0, then I will search for the binary search in the red area. Okay. So that would be binary search. So if not, then I'll search in the red area. That will be the searching for this array. Starting index will be 4. 4 is mid plus 1. And last index will be 7. So last. Yeah. So this is what I'm doing over here. Okay. So I'm searching at mid first. If it is found, I return the mid. Checking if the whatever search you get equal to 0. Then search in the purple area mid minus from 0 to mid minus 1. If not, go in the red part, mid plus 1 to last. And this is my binary search. Calculate the, declare the mid. Okay. Till it is first less than last. And simple binary search logic. And if it is as I need to return an integer, if I find, I'll return mid. If I don't find, I'll return minus. And this is returning from here to here. And then it is coming in the index and I'm storing that. Got the flow, guys? Understood the entire flow end to end? Let me go to the YouTube, guys, and confirm once. Got it, guys? Yes. And all good now? So I've pushed this code onto the GitHub. Very good. Others? Have you all got the entire end to end? So when I revisited the concept that time, you understood it? All good, guys, now? Okay. So I'll give you all 5-7 minutes. Try to do this code. If anyone has any difficulty, can post on the chat and mark your attendance meanwhile. Okay, so let me flip to the YouTube and check what anybody is commenting or asking doubts. So I guess all good. Amar sir has shared the attendance sheet also, guys. You have 2 minutes. Mark your attendance. If you have any doubts, put it on the chat. Okay, Amar sir, call it off for today. Have a nice weekend, guys. I'll see you all on Monday with the next topic. Okay.
Thank you. Thank you, students.